Hello, welcome everyone. So before we get started, I would encourage anyone who wants to come up to the front. We have a lot of open space. Can make it a little more of a come-together setting. No worries if you want to hang out in the back. Hey, I do it too. So again, thanks everyone for coming to my talk. I know there's a lot of really good and interesting talks going on right now, so I appreciate that you find this talk worth coming to. I hope that it will be educational and maybe a little bit entertaining. So quick introduction to myself. So I'm Alex. I work on the AWS SDK for Ruby team here at Amazon Web Services. I've been at Amazon for about 4 years, and at AWS a little bit more than a year. In my previous Amazon life, I worked on our inventory management systems. So if you've ever gone to Amazon and something has been out of stock, it might be partially my fault, and I apologize. So quick question, I kind of want to gauge things here. How many of you have used one of the versions of the Ruby SDK? How many of you have never used the Ruby SDK before? Cool, and we've got stuff for you too. How many of you have used V2 of the SDK already? And how many of you are using it in production? Awesome. Hopefully, I can encourage some of you guys to start to adopt V2 in production. I think there's a lot of really exciting stuff here. So let's get right into it. So we're covering 4 topics today. We're going to have a brief overview of the architecture of V2 of the SDK. We're going to talk a little bit about how you get started. So if you've never used it before, this is definitely the section where you're going to be interested, and we're going to show you how you get started. We're going to talk about new features that we have in version 2 of the SDK. And we're going to bring it all together with a short example using Ruby on Rails. So let's start with a brief overview of the architecture of V2 of the SDK. So we still use the same AWS SDK gem that you're using now. If you use V1, just going to be major version 2. But it's really a meta gem that contains 2 other gems that have the core logic. We have AWS SDK Core, which is our client-level abstractions over the AWS services, and AWS SDK Resources, which builds on top of Core to give you object-oriented abstractions. So we're going to start by talking about AWS SDK Core. So here's a rough idea of how we map the different AWS service actions to client methods. In short, for every AWS API method provided, we try to map that one-to-one to a Ruby operation. I mean, for the most part, it's literally, if the API calls list buckets in all caps, or list caps, bucket in caps, we just Rubyize it list_buckets. And the parameters work mostly the same way, so it's a one-to-one mapping. What we like to look at it as is parity plus. So you get your one-to-one mapping of the APIs, but we also provide parameter validation. So if something's missing that's required, we'll tell you about it. If you do a lot of testing, and I know I've talked to some of you here in the conference today who really would appreciate better mocking support. Well, in V2, we give you fully featured response stubs so that you don't have to write out a fully valid response. You can just write the parts you care about, and then we'll give you default values for everything else, which includes, and someone was asking about this, mocking for errors. We also have a plugin architecture. So some features like client-side encryption for S3, or just general stuff like signing, we have within a plugin architecture, which you can modify or add to, either with a pull request if you have a new feature that could be helpful, or locally for your own use of the SDK. Pagination, it's built in. So I know I've talked to a lot of you, and if you've been using V1, you've probably at some point had to write your own pagination logic. we now provide that at the client level. And we also have waiters, which I'm excited to show you later on. So back to our gem structure. What is AWS SDK resources? So resources gives you the object-oriented abstraction over our clients. So for example, in an S3 client, you just have your client, which has all the different methods that S3 provides to you. What resources will give you is a way to represent that as objects. So a bucket is an object, objects are objects, and so on. So this looks pretty similar to what we showed you before. The idea here is it's almost the same. You have the mapping of the HTTP call to a client method, which maps to a resource method that we assign to the appropriate resource object. So for example, if you're calling object.put, this will map in the bucket name and the key of the object based on how the object resource was built. So how do we get started with the SDK? If you have your laptop open and you want to try to install the SDK live here, I might race a bit ahead of you, but definitely feel free to give it a shot. So it's simple to install. We are in Ruby gems. So as you can see, the 3 gems we talked about here, AWS SDK core is stable. It is ready to use in production, and if you gem install AWS SDK core, you're good to go. For resources and the AWS-SDK V2, we're still in pre-release. So for now, if you're gem installing those, you have to use the --pre tag. You can also bundle the SDK in your Gemfile. So we're actually at least a couple version numbers ahead of this, but it's worth noting that in a Gemfile for a pre-release, you have to specify the version number you want. But you can just bundle AWS SDK, you get resources, you get core. Or you can just depend on AWS SDK core, and you're good to go. So again, raise of hands, how many V1 users? A lot of you. So you can use V1 and V2 in the same project. You don't have to migrate all at once. If you depend on the AWS SDK V1 gem, you have them in the same project. You can migrate one piece at a time and take smaller steps to get to where you need to be. Managing credentials. So if there is one thing to take away from this talk or any of the SDK talks, it is to never, ever, at any time ever, put your credentials in source code. Please do not do it. It can end very badly. We provide for you a lot of more secure ways to use credentials with our SDKs. For example, we will look within your environment variables. If you have the access key and the secret key in environment variables, we'll load from there. We have a shared credential file, which I'll talk more about in a second. We also look at EC2 instance profile credentials. Or you can plumb in your own credentials, which I would encourage you to get from some sort of secure source vending your credentials, not hard-coded or in a config file. So shared credential file. By default, we're going to look in your home directory under .aws/credentials. You can specify your own directory if you're building it yourself. It's a INI formatted file. If you're a user of the AWS CLI, and I know now many of you are, or if you use the other SDKs in your project, they all pull from the same shared credential file. You only need to write it once. And you can use different profiles, either in how you build your credential chain or by setting the AWS_profile environment variable. So here is what a credential file looks like. You can have multiple roles. So we have here, you could say, development and production with different keys and different secret access keys. And you can switch those with AWS profile. So we think this provides an easy but more secure way to manage your credentials. Within V2, we provide a lot of helpful documentation. This is especially important because our API our client APIs are built on top of JSON descriptions of the different services. Our resources are built on top of JSON descriptions. So we are still able to provide for you, with the tools that we've written, helpful and detailed documentation. I want to take you a second to show you what this looks like. So here we have the documentation page for V2 of the SDK. You see we break it out by service here. So if we look at EC2 and its client, we have all the different services broken out. So if we look at run instances, this is a pretty meaty service call. Have any of you actually written a run instances call by hand for, say, like a DevOps project you have? So we actually provide for you a formatting example with all the different parameters you can use, and we call out which ones are required and what kind of types we're looking for. So this will help you construct a valid call, even when the call is more complex. We also break out request parameters with detailed explanations of what they mean. And we document the response structure so that you can figure out what you're looking for from the response. Another thing that will become more clear later, we have the wait until method, and we've documented how waiters work here. For any service, you can look here to see what waiters we support and what client methods they're built on top of. We'll get a little more into that later. What you can also see is documentation of our object-oriented resources. So you'll see we have several classes in here, and these, for the most part, represent resource objects such as the base resource, instance, snapshot, and more. We also provide an interactive console. This existed in V1, but it's worth checking out again in V2. So it ships with the core gem. If you have resources as well, it will pull it in for you. It's built on top of Pry, or if you don't have Pry on your machine, it will automatically fall back to IRB. We also have helpers for client logging and HTTP wire tracing, which is definitely cool to check out. So let's see what this looks like. So I have a bash terminal here. AWS.RB is the name. So it provides for you an interactive console. So if I make a call like, let's say list objects. It will print the response that you get from the service. So you can take a look at that if you're messing around trying to see what's going to happen in your code. We also show you the low-level client operation that was called, how long it took, the response you got from the server. You can also use wire tracing with the -v flag for verbose. So if we make another call here, say head bucket, yep, bucket name. So it will show you the request that we made over the wire and the response that we got back from the server. This is really handy anytime something is breaking that you don't think should, so you can try to figure out, was there a problem over the wire? Was there a problem with your code? It really helps separate that out, so it's a feature I'd encourage you to use. So speaking of features, let's go into some of the features we'd like to highlight about V2 of the SDK. So the three features I want to really dive into are resources, pagination, and waiters. We're going to start by talking about resources. So I know some of you are doing DevOps here, and you've probably had to manage at some point large fleets of EC2 instances. In one case I was dealing with, I had a system that I maintain where we would be spinning up hundreds of EC2 instances per day, doing some data processing and spinning them down. What I learned a few weeks into this is we weren't cleaning up properly, and I had a few dozen instances just sitting there doing nothing. So how do we solve that problem? Well, in V1 of the SDK, it's fairly simple with the higher level abstractions we give you. You loop over your instances, and you call terminate. In V2 of the SDK, we do provide a batch operation for you. So you can simply say ec2.instances, which will give you a collection of your instances, .terminate, and they all go away. So quick quiz question. Raise your hand if you want to answer. If we have 100 instances, and I make this call with V1 or this call with V2, how many calls are each of those going to make? Well, in V1, we're looping over the instances and calling terminate. Yeah. Right. So 2 calls, 1 for the describe, 1 for the terminate in V2, and n+1 for V1. So we're going to make 101 calls versus 2. So I know some of you I've talked to have already written batching support within V1 to try to replicate this behavior. Now it comes out of the box. You also probably want to not kill all of your instances. Maybe you want to be a little bit more discriminate. So obviously, if you're killing an instance, it's probably running, but you may also have issues like tags that you want to make sure you handle properly. So here's what it looks like on the client level. You can call describe instances with filters, filtering for values such as state, tags you've put on it, or anything else. We provide a lot of filters for EC2. Then we collect them into an array, call a batch terminate. 2 API calls, fair amount of code written. With V2 resources, you can plumb in any of the filters you can use for describe instances inside the ec2.instances collection builder. And again, it's a batch call. It saves you some code that you may have had to write in the past. So again, resource objects, it's a simple object-oriented abstraction over your clients. Because there's a lot less handwritten code, we have a very light abstraction layer. For example, if a new version of the S3 client comes out and it's adding new parameters to, say, your getObject call, you just get those. You can add those into your calls, and they work. We've improved memoization. Some of our V1 calls are very chatty. You could get attributes, and it's going to call, say, described instances where you weren't necessarily expecting that. Here, resources will wait till the last possible moment and will only make system calls when you expect them to. We have improved batching support, as we showed in our examples, and resources are integrated with waiters and pagination. So you can develop at the client or the resource level and get these features. So let's go for a live demo. So here we have the interactive console open. And I'm going to create an S3 resource object. So each resource object comes with a built-in client. You can pass in your own if you have a client with special parameters. We can create an S3 bucket resource object. And note that we haven't made a system call yet. I could use any bucket name here, and it's going to wait until it has to make a system call. If you look at bucket.objects, it's a collection type that we've provided that gives you those batching operations on top of S3 objects. So you can see in the bucket we have a set of videos and pictures. Real simple bucket like you might have for family stuff or the crazy things your pets do. One nice thing about this is we provide all of the features of Ruby enumerable. But we can also, as with EC2 instances, pass in different filters or other parameters you would make into list objects. So here we've split out our videos. We can also use the enumerable call reject. So let's say that we want to filter out anything that's an MP4 file. Okay, that's interesting. Oh, it's pulling out the string here because for videos, I did the map where I didn't have to. Okay, pardon the live demo error, here we go. So here's everything but the MP4s. And of course, like any batch operation, we can just delete all our videos, 2 calls, and they're gone. So let's talk a bit about pagination. How many of you maintain buckets that have well over 1,000 objects in them? So most of you have run into pagination in the past. What would it look like using the V1 lower level client to try to iterate properly over a bucket that has more than 1,000 objects? There's a fair amount of logic here, and some of you are probably nodding your heads like, yes, I've done this before. So if we're using the V2 client with built-in pagination, what does it look like? Much, much simpler. You can emit each object to a block. We handle determining the marker. We handle determining when there's no more truncation. You can just loop over your objects and do whatever operation you want to do on them, such as collecting the keys in this case. In V2 resources, it's even a little bit simpler. You can use that object collection, iterate over it, do whatever operation you want to do with each object in turn. It's all handled behind the scenes for you. So all client responses are automatically paginated. We decorate them with the pageable response class that gives you helper methods such as next page, last page, or ways to emit each object to a block. Many of our V1 higher level abstractions were just ways to implement pagination, and they can be replaced at the client level now. Last, I'd like to talk about waiters. So when you create an EC2 instance, you get a response back right away. 200, we're making your instance. Often you have to wait until it's available to do your next operation. So some of you have probably written something like this, or have invented the wheel for your own application to be able to properly wait on an instance to either appear or fail to be running. I see some laughing in the crowd, so this seems like, yeah, many people I've talked to have run the same kind of thing. And there's a lot of code that you really feel like you should not be writing. So using the V2 client, how do we do the same thing? One-liner. Wait until instance running, or you can do instance stopped, instance terminated. Pass in your instance, and it will wait until it's running and return it to you. Using Amazon S3, waiting for an object to exist. In the past, I've been writing asynchronous applications where some process is writing objects to S3, another is trying to consume them down the road. Obviously, when you have any kind of asynchronous processes, you don't know if the object has been written yet. So we have to wait for it to exist. Using the client, it's simple. As we've seen before, you give it the bucket name, you give it the key, and we have a built-in waiter to do this. Using V2 resources, it's much the same. Because the bucket and the object provide for you the bucket name and the key, it's just plumbed right into that same client call. These two lines are equivalent. So waiters, we're pulling client requests for success and failure states. You can configure them. If you get throttled a lot, and I know I've talked to some of you who do, you can decrease your polling frequency, or you can also fail fast, not wait very long and then fail, or wait for a long time until the object appears. So let's take a look at a live demo. So if you look at the client, the waiter names are provided to you within any client with the waiter names method. So let's take a look at an object here. Or we'll call it hello, reinvent. We'll wait until it exists, and then get the body and read it. It's not there, 404. Wait for a polling period, 404 again. Let's make it exist. Next polling period. There it is. So really simple to do, makes a lot of these problems I know you've been having easier. So let's take a look at a Ruby on Rails example and bring this all together. So we have something called the Todo Sample App. How many of you follow our developer blog? So it's definitely something I think you should check out. We have this sample application on GitHub. And the idea here is this is as simple of a task manager as you can get. One pager, you can create, delete, mark some incomplete, mark it incomplete. Mostly designed to be simple enough that if you know Rails, you can understand it and focus on the AWS stuff that we're doing instead of focusing on figuring out what the Rails app is even doing in the first place. So let's take a look at this application. So as you can see, it's an extremely sophisticated user interface. So we can add my first task, because there's lots to do with our new manager here. Maybe too much. So hey, we're done. We've made a task. Don't really want to do that. Really, really simple task manager. So what I'd like to do is add a feature to it. So if the task states change, we want to notify any users that want to know about this. We want to be able to support multiple delivery methods. We want to do this over email. We want to do this over SMS. And this needs to scale because as a simple task manager, it's going to be a huge hit and everyone's going to want to use it. So we can use Amazon SNS and integrate with that to do what we need. It supports email. It supports SMS. For that matter, it supports much more than that, such as push notifications. It handles the scaling for you. You make one call, and it delivers everything, whether you have 1 subscriber or 1 million. And the resource APIs support SNS. So we're going to go a little bit quickly through this, so you're probably not going to be able to live code along if you're trying that. I would definitely encourage you to check this out on video, so you can pause, stop, rewind, and skip ahead as you need. But we have everything here you need to implement this feature. So make sure you have AWS SDK resources in your Gemfile. We add a form to the index page. Now, there's a lot going on here, but the gist is we have 2 form tags, one to populate an SMS subscriber and one to populate an email subscriber. Routes, we have 2 routes, one for each post action. Simple enough. We create a controller for our subscriptions. So if we need to create an SMS subscription, we plumb that through to our subscription pseudo class. If we need to create an email subscription, we plumb that through to our email pseudo class, and we just specify what endpoint SNS is going to need and redirect back to our page. The subscription pseudo model looks like this. Remember, when you create a resource object, it is not going to make a service call unless it has to. So the fact that we're creating a new resource, we're not going to be making a bunch of calls over the wire that aren't necessary, and we can use that to simplify our code. So what you'll see here is we have 3 calls related to the SDK. One to build a topic, one to create a new subscription using the data from the form, and one to publish a message. In the task controller, for each task action, we want to add a publishing notification. We're not writing all this code. We're just writing one line in it. So we say we created a new task, we plumb through the task name, add a title to the message, and we can send that along. So what did we do? Every time the task status changes, we publish a status message using Amazon SNS, which handles the delivery and scaling. And using the resource APIs, we eliminated some code duplication. So what does our application look like now? So now we have a form to add subscriptions. We can subscribe an email to it. And if I go to the email account I made for this, we have a subscription confirmation. This is all handled for you by SNS. So we confirm our subscription, and we start doing stuff. Make a task. Maybe we don't have so much to do. We delete that. This is done. This isn't done anymore. Okay, maybe it is. So we start doing a lot of operations. What happened to our email account? Well, everything's there. You're subscribed. You're following along with all the updates to this task manager application. And incidentally, my phone kept vibrating because when I was testing this, I subscribed my phone too. So looks like no one else is subscribed. No one else's phone is going off. So in conclusion, you can use V2 of the SDK today. Gem install AWS SDK -- pre, you're on V2, you can start messing around with all the features that we've talked about today. And if you use AWS SDK core, it's stable, we're not making backwards incompatible changes, you can use it in production and get the benefits such as pagination and waiters starting today. You can use V1 and V2 in the same project. Again, you do not have to migrate everything at once. You can migrate things piecemeal, test carefully, make sure everything's good to go. We support that. Not yet stable is AWS SDK resources and major version 2 of the AWS SDK gem. We are converging on a stable version. When we have more to say, we'll be letting you know. We're hoping to get there soon. We encourage you to contribute to the SDK. We're open source, we're on GitHub. You can file issues with any bugs you're having. You can contribute features. You can contribute resource descriptions. You can contribute pagination support. You can contribute new waiters if there's something we don't have that you need to use. And as a bonus, multiple SDKs, including Java and Python, use the same resource descriptions, the same waiters as we do. So if you provide your work, you can have a wide impact. As a bonus and example, we have an AWS CloudFormation resource definition. That came from a customer of the Ruby SDK. We worked with them to get things straightened out, and we're hugely grateful. It's a lot of benefit to our customers to have that CloudFormation resource. We have a developer blog at ruby.awsblog.com, which includes tips, tricks, and the development history of V2. That end-to-end Rails tutorial we were talking about before. And we always welcome your requests. I've heard a lot of great feedback here at the conference about things such as explaining error handling, feedback that we want to take and contribute back to the blog. So that's what we have for today. I thank everyone for coming and for your attention. And we have time for questions. So if we have any questions, raise your hand. Shoot. So, Trevor, you seem like you want to answer that question. So the question was, are we trying to make it easier to get ARNs from resources?
So in theory, it should be fairly easy to construct an ARN given that you know the service you're talking to, the identifier for the resource, the region that you're operating in, those types of
So to recap his answer, it's something we're looking into. It's something we want to add, but we're not there yet. Do we have any more questions? Lambda Ruby. Did we launch that today?
Yes, it went out today at 11 o'clock for AWS Lambda, Ruby SDK client for AWS Lambda.
Yeah, in fact, if we go back to the documentation page, it's right here.
So instead of Node, instead of having an execute JavaScript, we have an execute Ruby. Is that on the future?
I don't know. That would be a good question to bring forward to the new services booths here today, or if they have a presentation later on. Yeah. And if you want to meet up in the Q&A section afterwards, I can take down your info and get back to you with that. Any more questions? So let's take a look at what we have for waiters here. I mean, the general idea is we want to pull on a single change and then return. I don't know if we've added that for, I don't think we have any waiters on SNS. Do we have it for SQS? Yeah. Yeah. So waiters are designed for polling. So more or less that's what they're designed for. You can definitely, we hope that V2 of the SDK makes it easier for you to write your own abstractions like that. I think it's a good feature request. I think that's something we can take back and talk about, and then kind of communicate back through the blog if it's something that we're looking at. So I think we have time for one more question if someone would like to. Yes?
Are you planning on creating like a version 3, version 4, or is 2 awesome now?
So that's a great question. He's asking, are we planning on a version 3 and a version 4? So one of the motivations behind creating V2 of the SDK was to take out some of the hand-coded operational burden, and we've tried to make all of our abstractions as simple as possible because we really, really want to avoid incrementing major versions if we don't have to. So by having the lightest weight layer over the client that we can, by having very simple object-oriented abstractions and resources, we're putting in a lot of work to try to avoid doing just that and to have V2 be the canonical version of the SDK going forward. Anyways, we are going to take this out to the Q&A section outside the hall here. I appreciate everyone's time, and I'd like to meet anyone who'd like to talk about how they're using the SDK here at the Q&A section. So even if you don't have a question, feel free to stop by. And please remember to give me feedback on how I did on this presentation, and I think you can get some cool AWS swag for doing so. So thanks everyone for your attention.